Mark. So my name is Valerio De Angelis. I'm originally from Italy. I was born in near Naples and moved to the United States in '94, where I got my PhD in chemical engineering at UC Santa Barbara. And I've met Mark, I would say, shortly after that. And we have been, as Mark was saying, long friends. So in 2010, I joined the City University of New York Energy Institute and started to work on energy storage technologies, and mostly finding ways to develop technologies that were designed for the electric grid and would allow us to decarbonize the grid and increase the amount of renewable that we can accommodate on the electric grid. After having been at the university for 10 years, I moved to Sandia National Labs, where I managed the energy storage system integration program. And at Sandia, we're extremely lucky because we get to build batteries and test batteries from very small size to enormous container scale battery systems. So, and I'm happy to share whatever knowledge I have on this very vast, interesting topic, and yeah, see where the conversation goes. Thanks again, Mark.
Valerio, I'm curious, when did you find that you were so interested in batteries? I mean, it's such a big problem and you have such an important role at Sandia. What was it about this topic that captivated your interest?
So energy storage and batteries will give to the electric grid a different level of control. Until battery technologies became available to a level of scale and maturity that can be used on the grid, electricity was basically produced at the same time in which it is consumed.
Right.
And that creates a very inefficient system in which to provide that final peak power that might be required only for a few hours of the day, we have to maintain peaker plants, which are amongst the most expensive and the least environmentally friendly plants. So energy storage and renewable were a way to kind of close that gap, give an alternative in which energy can be stored. And storage is such an important part of everything. You know, in fact, legend goes that cities could start only after people learn how to master pottery, because that allowed them to store seeds, and so they could rely on a food supply. And so energy storage for the grid is kind of like the same missing element.
I'm just reminded that I'm right now listening to the biography of Benjamin Franklin and all of the original work that he did in electricity. And the interesting part, now that I'm thinking about it, was being able to store that which he was capturing from the lightning.
And in fact, batteries started with Volta, who found a way to just use some very basic metals to store from some of the electricity and then use it to provide power back. It's just that over the last, I will say, now 30 years, energy storage has come to an inflection point thanks to all the progress that have been made in consumer electronics. Lithium-ion batteries, which are the one that now we all hear about, were originally studied since the 70s by some eminent, in fact, the group that invented the lithium-ion battery got the Nobel Prize a couple of years ago. But in 1990, Sony got to a point in which they could productize the technology. And what they did is they developed the battery cell, which is just about the same dimension of the AA that we use in our remote control. And then they started to use those batteries in consumer electronics, like the Vio laptop, which was just the best laptop out there, mostly because the batteries were so good and they could pack so much power into the laptop itself. And then from there, the lithium-ion batteries grew and then became the batteries that now we use in our cell phones and power our consumer electronics. About the same, about 10 or 15 years later, the idea of using the same small batteries started to enter the car industry. And so one of the magic of Tesla, in fact, is that they managed to take these extremely small batteries, which again, they're named 18650, and the dimensions are in the name. So they're about less than an inch in diameter and about a couple of inches in height. And Tesla packs about 10,000 of these little cells into a battery pack, enormous battery pack that lies flat at the bottom of the car.
The whole bottom of the car, right?
Yeah, and that allows them to keep going for 300-400 miles now. And then there was this very strange moment in which there was oversupply of 18650 batteries, and laptop companies were moving to different type of cells, like the pouch flat cells that now are commonly used in laptops and in consumer electronics. So people started to package these batteries in energy storage systems that they could put on the electric grid. And that, if you go back, that is about the time when I joined the industry in 2010, 2011. In New Jersey, there is a fairly forward-looking electricity operator, PJM, that started to use lithium-ion batteries for frequency regulations. So frequency regulation is trying to solve that same problem that we were discussing at the beginning, where electricity is produced at the same time in which it's consumed. It's consumed, but sometimes there is a little bit of imbalance, and that causes the frequency to kind of shift. And that's what this lithium-ion system started, and then they grew from there.
I have several questions, but one of them, another part of this sustainability conversation is environmental and the environmental pandemic that we're in, and the environmental crisis that we're in right now. And as we rush to the electrification of everything and the reliance of on batteries, tell me what the impact is of like lithium mining and those kinds of things, being able to find these rare metals to power the batteries, because there's a trade-off here, isn't there?
Yeah, and there is a trade-off, and there are several extremely brilliant scientists working on this problem, trying to do a couple of things. One of them is to decrease, for example, the amount of cobalt that you find in some of these batteries.
Cobalt.
The cobalt. So
yes.
the way lithium-ion batteries work, there is a graphite on one side, and there is some kind of a metal oxide on the other side. And this metal oxide is the one that keeps the lithium ions in it. And there are different types of metal oxides that can be used. It started with what were called NMC cells that used a lot of cobalt. But then now over time, people are decreasing the amount of cobalt. And that will help. At the same time, like with every industrial process, as people learn how to mine these materials better, the environmental impact might decrease. And then ultimately, what I hope is going to happen, as we start having large amounts of electric cars and energy storage system based on lithium-ion batteries, the recycling infrastructure will improve.
Right.
See, in the United States, we all use lead-acid batteries in our cars, but most of the lead in the lead-acid batteries in the cars comes from recycled lead. And the industry has been extremely effective in making sure that we use most of the lead that is in circulation. Now, lithium batteries are not as easy to recycle as lead-acid batteries because there are many different components that go into it. But I think that that's where the ingenuity, as the production scales and utilization scale, will bring us to a point where we learn how to recycle these materials effectively. Then there are more technical things happening, but go ahead.
Well, I know when you and I talk, you get boom, 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 boom pretty quickly. We're very, very deep in the technology, and I want to take a little bit of a different shift. So Sandia National Labs, it's government-funded labs, and you're slated with solving these very, very, very big problems that we have. And I know that you and I have talked about there's maybe 1,000 people like you in the world, who are really looking at these problems. I'm curious about, you have this idea that a lot of this research should be open source and available to people to share this research. Yet I think there's probably a competitive edge to inventing the perfect battery, if you will. So is there something going on in the industry between this open source good for mankind versus what's good for the venture capital world, venture backed businesses?
Yeah, so there are various parts to this. One is once you get the lithium-ion cells, you still need to put them into systems. And the process of putting the lithium-ion batteries into systems is expensive. And I feel, and we feel that cost can be controlled. So people should be able to buy lithium-ion batteries from whatever producer, and they should be able to use it effectively in a system, whether it's an energy storage system for their house or is a larger energy storage system, which is used by a utility. And the problem there is that the software, power electronics, control systems that allow that battery to charge and recharge are not widely available. Oh. And that's definitely something that can be solved. And eventually, companies like Samsung or LG or Tesla, Panasonic will make these brilliant lithium-ion batteries. And they will become, I hope, as reliable and easy to procure as solar panels, right?
Right.
And imagine if you get to a place where using a lithium-ion battery pack is just as easy as installing a solar panel on the roof. One of the reasons solar costs have dropped so much is not as much because of the cost of the panel, but because everything that comes with it has become simpler. To the point where, and maybe I'm exaggerating, to the point where you and I could buy a solar system and put it on a roof in a couple of days, because everything is so standard. And that level of openness and ability to interchange batteries with power electronics and software, I think eventually will take place in the energy storage industry. Now, will it take 5 years, 10 years? That's hard to say.
That was going to be my next question, because we've seen these power walls, right? These batteries that fit along the inside a garage, and they're just extremely expensive. So how long does it take for, I don't know that we can wait for the costs of that to come down by the time we're fully electric. I mean, General Motors, it says it's between 2030, 2035, we're going to be well on the way. Will battery technology have come down by that time? It's not that far from now. Will they, to where it's affordable?
So, let me put it to you in these terms. In principle, one can buy lithium-ion batteries now, if you buy a lot of them, at a cost that is, call it $200 a kilowatt hour, in a rough order, right? It could be more, it could be less. And so then for a power wall kind of system, that will be like maybe multiplied by the 10 kilowatt hour that you will need. It's maybe a couple of $1,000. And then you should be able to put some electronics around it for another $500. So it should be possible, in principle, to have energy storage systems that only cost like a couple of $1,000, as long as they're easy to install, right? And they're easy to manage, and then they become easily part of your house. And that, I think, will happen. It has happened in the solar industry, and it will happen also in the storage industry. Now, in addition to lithium-ion, and there are other energy storage technologies that can be used on the grid. So the lithium-ion batteries that we have been discussed, they are the choice, of course, for consumer electronics. They are the choice for electric cars, at least at this point. And they work for energy storage systems that only need to provide power for 1 to 2 hours, maximum 4 hours. But when you think about the problem of integrating renewable, you are going now to a situation where you may need 24 hours or 150 hours. Some people are saying you may need months. And so for that, there is a whole other set of technologies that are coming. Some are hydrogen-based, some are gravity-based, some are thermal storage-based. And some of them are extremely interesting because some of them will take existing infrastructure, like the conventional power plants that we have been using based on coal, for example, and turn it into power plants that can use green hydrogen, or they can use some other form of thermal storage to run most of the same infrastructure, but using renewable technologies.
Valerio, I am so thrilled that you are working on these problems with your colleagues, and I can't wait to see some of these projections come true.
Thank you.